And to explain this question in two ways. We've got our trapezia here. Let's look at the smaller one to start with. So I know that I don't know any of the side lengths. But I know that these three are the same, so I'm going to call them all A, and then the bottom one B. This is method one. This is how I did it. Um, we know the angles are 60, 60, 120, 120. I'm not going to write them on, but I'm aware of that. And then the same is going to go for this larger trapezium. We're actually told that it is a larger version of it. So this is also 60. These two are 60, which is going to give 120. You can see the angles are the same. Now that is actually not enough to say that they're necessarily similar, because a square and a rectangle have the same angles, but they're not similar. We can, however, see that the sides are the same here, A plus B, and A plus B. And this bottom one is 2A plus 2B. Okay, these three are the same. We haven't quite shown, actually, still that it's similar. I'm not going to go into detail on that because it's actually quite complex. So I'm just from now on going to assume that, yeah, it is similar because we are told that in the question. But you should be able to prove it if you weren't told it, but that would be a more complicated problem. Now, here's the thing. We can see that the base is actually twice all the other sides, okay? Because this could be written as 2A plus B. And therefore, it follows, because they're similar, that it must be that B is equal to 2A. And I can replace everything with this one variable now, just A by itself, or one unknown, I should say. So this is going to be 2A. A plus 2A is now going to be 3A. So we can just work in terms of A. And this one here is going to be 6A. Okay, and so if I add all of these up, I get 3A plus 3A plus 3A, 9A, plus 6A, 15A, and that is equal to my perimeter of 18. I'm bringing that in now. What we're actually interested in is the perimeter of the smaller trapezium, which is 5A. So I don't need to work out A, I can just divide through by 3. 5A is equal to 6. That is our answer to this question. Method 2. This is how the answers actually do it. So the answers really work on the fact that, let's look at the bigger trapezium to start with. You can actually, because you can see it a bit better, the fact that we can split this trapezium into 3 equilateral triangles. Now we can actually kind of prove that. I'm just going to prove it verbally. It's clear that this is 60 and this here is 120. So if I choose to bisect it, I'm going to get 60, and where it meets down here will also be 60. This will then also be 60. And I can do the same up here. This will be 60. If I choose to bisect it, this will be 60. So that must be 60 and that must be 60. So we must be able to split it into 3 equilateral triangles. Worth learning about this method, actually, because I've seen other questions on junior Olympiads and similar where you have to split such trapeziums into equilateral triangles. After that, because we've basically shown that they're equilateral triangles, we can say, you know what, I can do the same for this one down here, and therefore I've got A, and I've got 2A. And that's really useful because we've basically shown using equilateral triangles that the base is twice the other sides. So this must be 3A, and then you make a similar sort of argument. We've avoided B, and this here must be 6A. And then the end of the question works out in a very similar way. So 2 methods for this question. I think my way is a bit more complicated, to be fair, but I don't know, it was more intuitive to me to do that. Make A, and have B. Okay, use similarity to show that B is actually equal to 2A, and then from that we get the perimeter of the larger one, and hence the smaller one. Method 2 was to split it into equilateral triangles, hence spot that actually the base is twice the other lengths. Okay, just a different way of getting it, and then the method follows in the same way. Okay, well done on this question.